All right, here is section 11.2. 11.2 is entitled Permutations. And you're going to see very quickly, well, hopefully see, the difference between 11.1 and 11.2. Next class we'll get to combinations, which is 11.3. And let's take a look at what's going on here. Dylan is enjoying a comedy night at a local hotspot. It is now open mic time and he has the opportunity to make the audience laugh. If he has 8 jokes to deliver at a comedy show, in how many orders could this happen? I'm going to say immediately, you have to see that with permutations, there's no repetition. Yep, if I can spell that right. Few times in a single show do you want to hear the same joke told twice, right? The joke is told once, it's done. You usually don't come back to that, right? Or if you're telling a story, if you have several parts of your story to tell, you usually don't tell it again and again and again. We already heard it, right? So if we have 8 jokes to deliver, we have essentially 8 categories. Does that make sense? When he goes and stands up to tell his jokes, the first joke he tells, how many choices does he have to pull from? 8. But after he tells that first joke, is he going to have 8 more choices? No, because nobody wants to hear the same one twice, or usually they don't. Then what?
6.
Then
5, 4, 3.
And of course, after he's down to the very last one, he's told almost all of them, he only has 1 left. And then we use the fundamental counting principle or the principle from it to get our answer, and that is to multiply these together. And that is how many ways he can tell the 8 jokes he has. Does that make sense? He has to tell 8 jokes, 8 categories. The first joke he tells, he has 8 choices to pull from. But once he uses them, there's no repetition when you're dealing with permutations. Remember that. It's going to be different from combinations. There's no repetition with permutations. You take it out, once you use it, it's gone. Answer?
40,320.
Okay, let's see here. And you got it. Good job. Does that make sense, everybody? Okay? And that's what this section is built upon. Okay? All right, let's keep going. So, next one. There are 5 performers who will present their comedy acts this weekend at a comedy club. How many different ways are there to schedule their appearances? This is just another way of doing the same thing. But instead of having jokes to tell, you have performers to line up. Does that make sense? The jokes are like the performers. We have 5 different performers that need to perform. If we're creating a lineup, the person who goes first, how many choices do we have there? 5, of course. But once that person goes, do we want to see that person again necessarily? No. So then it's 4, 3, 2, 1. No repetition. Does that make sense, guys? Okay, any questions about that at all? Answer?
120.
Good job. All right, let's take a look at this one. There are 5 performers who will present their comedy acts this weekend at a comedy club. Okay, looking very similar to what we just had. I'm leaving these up because I want you to see kind of the way that they work and have a little bit of a sample or example. So here's our first example. Here's our second. Here's our third. Okay, one of the performers insists on being the last one of the evening. Stop right there. What does that tell us immediately about this spot right here?
You only have 1 choice.
You have 1 choice for sure. But because, without a doubt, one of them has to go there, what does that say about this? There's only 4 choices here now. Does that make sense, guys? Because one, before you even start doing the lineup, before you even start creating your show, one insists on being last, meaning that you've already taken one out of the pile. Does that make sense, guys? Okay? Which means that when you start to do your lineups for person or comic 1, you only have 4 to choose from. Does that make sense, guys? Then here we go. 3, 2, 1, count it down. This is okay. Does that make sense? Okay? There's nothing wrong with having one choice for 4 and one choice for 5. Answer for that one? 24. All right, let's take a look at this bookshelf problem. You need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? Answer to this. Can you say it out loud how we would write it down?
10, 9, 8, 7.
Not, that's your problem probably.
Oh, okay.
But for ours it would be
7,
7, 6, 5, 4, 3, 2, 1. And the reason why we know it's just like the first example we did is because they did not say anything about, well, we want a book to be in this specific spot, or this specific spot, or so-and-so. It didn't give you any other specifications. It said, we just need to arrange 7 books, top to bottom. Make sense, or left to right? All right, so there it is. So this one's pretty easy. Okay,
Your
now-
answer was 5,040?
what was that?
What was the answer?
I don't know.
5,040.
Okay, I just wanted to
Okay,
know.
all right, good. Okay, now, what we have just done in these examples here, specifically these two, is we've done what's called a factorial, okay? And a factorial is the concept that if we have some number n, okay, some number n, the factorial of that is you would take n times n minus 1 times n minus 2 all the way down to 1. What do we mean by that? Some examples. If we had 8 factorial, that is the same as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Does that make sense? 5 factorial is the same as 5 times 4 times 3 times 2 times 1. What would 3 factorial be?
3 times 2.
3 times 2 times 1. If I had 1 million factorial, it would be 1 million times 999,999 times 999,998. What is a factorial? Essentially it's a shorthand for doing this. And there's a button on your calculator that does it for you. And we're going to learn that right now. Okay? So a factorial takes the number that is in front of the exclamation point, starts at that, and multiplies it by 1 less all the way down to 1. Does that make sense? That's what a factorial is. It's just shorthand for that. So let's take a look at our problem here. Okay, so our problem is 30 factorial divided by 26 factorial. We'll work on the calculator in a moment. 30 factorial divided by 26 factorial. If I were to write this out, what would 30 factorial be? 30 times what? 29 times 28, 27, 26, 25, 24. I'm not going to go all the way down. 22, 21, 20, oops. 19, 18, all the way down to where? 1. Everybody agree with me? Any questions about that? And I'll show you how to do it in your calculator in a moment. Okay? What would 26 factorial be? Where would we start with 26 factorial?
26 and count down.
26, 25, 24, 23, 22, 21, 20, 19, 18, all the way down to 1. Everybody agree? All right? Now, there are 2 ways to do this problem. The first way, I'm doing it by hand. I'm going to show you here. The second way, I'm going to show you on your calculator. Does that make sense? Okay. There's a reason why I lined these up, isn't there? Because ultimately, I don't need to actually calculate 30 all the way down to 1 and 26 down to 1 and divide the 2 to get the answer. Everything from 26 down will cancel out which means the only ones that are relevant are 30 times 29 times 28 times 27. That would be your answer. Somebody tell me what that is.
657,720.
Let's type that in and see.
Okay, wait a minute. Never mind, go ahead.
Okay. Now your question, Sherry?
Okay, why did you stop at 27? Oh, okay, because it's 26.
Because they overlap at 26 down. Does that make sense? Okay, now, let me re-explain what I just did, and then I'm going to show you how to do this without the shortcut. But the thing is, you need to know the shortcut, because we will use it a lot. Okay? You don't want to do it just on your calculator, because it won't always work out nicely for many of you. You need to know this shortcut. We will use it over and over and over again. Okay, let's explain. The problem was 30 factorial divided by 26 factorial. I'm not going to go and write this down every time. I wrote it like this so that you could see why it cancels. But when you get good, being right now, is that you need to see, okay, I've got 30 over 26. I know how factorials work. Because I know how factorials work, I know how they work, I know that at 26, they will begin overlapping, which means I know that all I have to do is take 30 times 29 times 28 times 27 to get my answer. Does that make sense, guys? Okay? I would never write this down. I only wrote it down so you understand why it's just this. Does that make sense? Okay? So when we do multiple problems in a moment, you will know that. In fact, I don't want to show you how to do it on your calculator just yet. Okay, I'll show you in a moment because I want you to do it this way first. Okay? All right, everybody got that? Any questions? All right, let's move on to the next one. Okay, perfect question. Here we go. 17 factorial over 14 factorial. Where can I stop?
15.
At 15. Does that make sense, everybody? Okay, take a look at this problem. I'm going to leave this one up just for now. 17 factorial over 14 factorial. I know they're going to start overlapping at 14. Does that make sense, guys? So that means my answer is going to be 17 times 16 times 15 alone. I don't include 14 because that's where they will start overlapping and canceling. Does that make sense, guys? Okay, what's the answer?
4,080.
4,080? Okay, thank you. And that's how you evaluate factorials. Okay?
Okay, and you don't even do the division, you just.
No, because the division is I've already canceled that part out. Does that make sense? I have shortcutted the division essentially. Okay?
Okay.
Now let's do this one. This is really easy. Where does it stop?
674.
674 is where it stops. So what's your answer?
674.
674. Because you know they start overlapping at 673, right? So anytime you see something divided by one less than it factorial, your answer is that one. Isn't that true? Because isn't this 674 times 673 all the way down to 1? And this one is 673 all the way down to 1. It all cancels. Does that make sense, guys? Okay? So there it is. The answer to that is 674. I'm not going to type it in. Okay? How about this one? What would the answer be to this one? Just stating what we would multiply. What would we multiply?
114 and 113.
Exactly, because they start overlapping at 112. Does that make sense, guys? Okay? I'm going to move on. Now, there is no shortcut for this. Okay? There is no shortcut for this, and this is where I want to show you how to use your calculator. I can't pull mine because obviously it's recording, but there's going to be an exclamation point button on your calculator. At least there should be. Okay? And what we're going to do right now is we're going to go figure out what 6 factorial is. On your calculator, some of you are going to need to either do 6 and then your exclamation point button, or the exclamation point button and then 6, but usually it's 6 and then the exclamation point.
Ours
Okay.
doesn't have an exclamation
I
point.
don't either.
Now,
I don't either.
it will, or at least it should.
These calculators are just ridiculous. Yeah, I mean, even the YouTube videos did not help. It's ridiculous. I hate this calculator.
I have the graphing and I
The
don't see
bookstore
Your
line.
graphing is under your math option. If you have a graphing calculator, it's going to be under the math option.
I don't even know what
Yeah,
the
and
math option is. What is that?
You don't have a graphing calculator, so it doesn't apply to you.
Oh, okay, good, thank God.
How about that? TI-30, no exclamation point.
Oh, that's what I have too, no exclamation point.
And the
Yes.
bookstore said that this was the calculator
No, you do have it.
where.
You're right. Okay. So under at the top of your calculator, it says there's a button. Second row is PRB.
Yeah.
If you hit that, your third option is an exclamation point.
Huh?
Okay.
You see that? Okay. So you're gonna put your number in, then hit the PRB button, then choose the third option, hit the equal sign. Does that make sense? You got yours?
I don't think it's the same one. Maybe it has
Okay, what
Oh.
is it supposed to
You
be?
got it?
Is that? Is it, you know what I mean? Is it supposed to be that DEG
Yeah,
line?
mine's a.
No, DEG doesn't make a difference.
Okay, that doesn't matter?
No.
So awesome, thank you.
Nope, you do have it right here. X factorial. You have to hit the second button to do that. All right, so in the event that you can't figure it out, almost always there's usually a tutorial online or there's a manual. Find the manual, figure out where your exclamation point or factorial button is. Almost every, and should be every scientific calculator should have it. It's a very basic function. So what's 6 factorial, everybody? Somebody tell me. Come on.
Yeah, 720.
720. Okay. What's 2 factorial? 2. Yes. So 6 factorial minus 2 factorial is what? 718. There's your answer. Okay?
Yay!
Let's move on. So there's no shortcut for problem number 9. Now, take a look at number 10.
Oh, okay.
Number 10, there's no shortcut either, but you should always do the stuff in parentheses first. Once you do that, the answer is or 2 factorial or simply 2. Does that make sense? Okay. Let's move on. Now, same thing here. There's no shortcut for this, but you should always do what first? What should you do first? Parentheses. 12 over 4 is? 3 factorial. The answer is what? 6. Good job. Next. Now, let's take a look at this one. All right. So let's look at this. Here's what you should do. You really don't need your calculator to do this. Like we saw before, you should do the stuff in parentheses first. 6 minus 3 is 3 factorial. Do we know how to do a problem like this without using your calculator? Sure we do. We know that this would stop at 3 or 4, whichever way you want to look at it, but 3, it's done, right? So your answer is 6 times 5 times 4, which is 120. And that's how you would do a problem like that. The reason why that is so important is because right now, this right that they just gave you is the formula for doing true permutations. N factorial over n minus r factorial, and we're going to use this in a moment. Very important. Okay, so you're going to see that formula come up, NPR, where n factorial over n minus r factorial is used. We're going to see that in a moment. Don't worry if you're not stressed. Here it is. Don't be stressed. We're about to do it right now. So, what we see here is 9p3. Let me zoom in just a little bit. This is 9p3. What they're saying, okay, what they're saying is we have 9 things to choose from. And we're taking 3 items at a time. How many different sets of 3 can we take? Does that make sense? Let's look at this one more time. This is where the section transitions a little. We have 9 items to choose from.
So
N is your number of items. We are taking 3 items from the 9 at a time. How many different permutations can we create?
So how many different groups of 3? can
How
we
many
make
groups
up?
of 3 can we make from the 9 with no repetition?
So
Does that make sense?
9 factorial over 9 minus 3.
Exactly. 9 factorial over 9 minus 3 factorial. That's how you do that. We're going to see some word problems in a moment that take this into account. But can you see how they taught you and built you through that? They didn't drop you right into doing it. Okay? So it's 9 factorial, 9 minus 3 factorial, which is 9 factorial over 6 factorial. You don't need a calculator necessarily to do this. Where does it stop at? 9 times 8 times? Stops there. Maybe some of you want to use a calculator. That's going to be what? 72 times 7. Answer?
504.
There are 504 ways to take groups of 3 from a bigger group of 9 with no repetition. Does that make sense? When we get to next class, which is combinations, you will get to see that done with repetition. Okay? Let's take a look at this one right here. 3p3. Okay, what's 3p3? 3 factorial. That's where that one comes from. Over 3 minus 3 factorial. What's that? 3 factorial over 0 factorial. What's that?
0?
It would just be 6.
1.
Always. Go put in your calculator 0 factorial for me.
It's 1.
It's 1. And so I want to make a little note here. 0 factorial always equals 1, which means that this is really 3 factorial over 1 or simply 6. You got it. Good job. Because 3 times 2 times 1, right? You gotta
okay,
do
yeah.
that part, right?
Okay.
Okay? You gotta do the numerator. So the answer is 6. All right? Okay. And so let's take a look at this one. 16p0. What would that be? I'm going to bring it down here so you have a sample. 16 factorial over what's on the bottom?
16 minus 0.
16 minus 0, which is 16 factorial over 16 factorial, which is 1. Careful. Anything over itself, right, is 1. In fact, whenever you see n6 something p0,
Answer's always 1.
answer's always 1. Okay? All right, here we go. Some applications, and then we're done. What time is it?
9:15.
Perfect. That'll be good. Just good enough to do a few problems, then we'll be done. A club with 6 members is to choose 3 officers: president, vice president, and secretary treasurer. If each office is to be held by one person and no person can hold more than one office, what's that another word for? No repetition. That's how you know it's a permutation. Does that make sense, guys? How many different ways can the offices be filled? We're going to use NPR. What is N, everybody? 6. You have 6 people to choose from. You cannot have repetition, which is why we know we're dealing with a permutation. How many groups are we taking at a time? Groups of what? 3. Because there are 3 positions: president, vice president, and secretary treasurer. I'm not going to do the math because we know how to do this, right? We just did several problems. This would be 6 factorial. Oops. 6 factorial over 6 minus 3 factorial, and you would go do the math for that. Does that make sense, guys?
Sir.
Okay. Let's go on. Okay, let's take a look at this one. For a segment of a radio show, a disc jockey can play 8 records. If there are 11 records to select from, in how many ways can the program for the segment be arranged? Is 8 the N?
No, it's the R.
No, it's the R. You have 11 records to choose from. Nobody wants to hear the same thing twice usually. And you're going to play 8 out of those 11. And so it would be 11 factorial over 11 minus 8 factorial. Do the math, finish the problem. Does that make sense, guys? Okay, I'm not going to do the math because we did several of them. And I've already shown you the shortcut. Okay, key word. How do you know that it's permutations? What's the key word or phrase right there?
There are no ties.
No ties. Why do I keep driving this home? Because next section, when we get to 11.3 combinations, the back end of the section will ask you to determine which one is which. And you're going to have to look for key words like no ties. That will be your indicator that you're going to use permutations. If you are allowed ties, then you would use combinations. We're not there yet though, okay? Race in which 8 automobiles are entered. What's our N? 8. No ties. P. How many ways can the first 3 finishers come in? 3. So go finish that. I'm not going to do that one, okay? But you know the setup, all right? Do one more and call it a day. At a benefit concert, 11 bands have volunteered to perform, but there is only enough time for 7 of the bands to play. How many lineups are possible? Okay, what's our N? 11. We don't want to have repetition in the bands. How many can get to play? 7. Okay. Now, at the very end of this section is a tricky problem. Use the help me solve this to do it, and you'll be able to figure it out. Okay? That'll do it. Really, really good work, guys. Nicely done. 11-1, 11-2, next class.